Hi everyone, this is CS6365 project presentation. Our project topic is driver behaviors tracking using smartphone sensors. My name is QianYu. Today I will be collaborating with my partner YahuiKe to finish this presentation. Currently, more and more people own the cars. As one of the surveys shows that every American has 2.5 vehicles. As the vehicles become more on the road, it's really important to increase the driving skills to avoid the accident happen. Driver behaviors strongly impact the traffic security and cause the vast majority of motor vehicles accidents. So how to solve this problem? Our group come up with an driver behavior tracking application. Driver monitor and analysis, or driver behavior profiling, is the process of automatically collecting drivers' data and apply a computational model to them in order to generate a safety score for the driver. And this application will have widely use. It will not only help people monitor their driving behaviors, but also an easy tool for insurance company and the policeman. Our application is an Android-based mobile application. We collect the sensor data and convert to graphs show the movement of drivers. When we collect data, we will generate a log file, which is used for train and test the model of drivers' behaviors. This is the basic pipeline of our application. We get Android smartphone sensor data and translate sensor data to Earth's coordinate system. Then we generate the parameter we need and use machine learning algorithm to train and test the model. Finally, we use those data to draw the graph and evaluate the result. Those are the examples of what kind of sensor data we collect from the Android smartphone. From the acceleration, gyroscope, magnetometer, gravity, and rotation, we can calculate the three-dimensional direction of the smartphone. This can show the movement of the vehicles. On the left-hand side is what our front end looks like, and on the right-hand side is what our log file looks like and the location to store our log file. This is the demo of our application. As you can see, the graph is changed as increased, and we will talk about how to distinguish the on the bottom 4 buttons, and those 4 buttons is used to correct various behaviors. And we use this application to collect more data in future. In our model, the algorithm we use to train our model, we have 3 initial options: support vector machine, artificial neural networks, and decision tree. Since our data is binary with labels, it's better to choose machine learning algorithm from supervised learning to distinguish the driver's behaviors. And these are three machine learning algorithm definitions. After comparing those 3 algorithms, we find that support vector machine has the best performance of accuracy. So we use the support vector machine with kernel function. The kernel function we choose is Gauss's function. This is the equation of the activation function, and this function is good to deal with overfitting and underfittings.
Thank you, Jian, for presenting the first part. I will present the second part. For this part, I will introduce the phone coordination, some basic results from our sensor data, and also the future works we need to improve as well. So for a phone coordination, we know that every object in the universe has its own coordination. The smartphone has its own coordination as well, which is presented by XYZ axis. So the smartphone also has 3 rotation dimensions. Depending on how we mount the smartphone in the car, we need to transfer the sensor data from smartphone coordination to the vehicle's coordination, such that we can use the smartphone sensor data to present the vehicle's speed acceleration, and angular speed, so we can define a driver's behavior using this data. As the picture shows how a smartphone is mounted here, the z-axis acceleration value will present the vehicle speed. We can use this value to record the driver's acceleration, slowdown pattern, and also the frequencies of the slowdown, speed up, which is very important to define a driver's behavior. The rotation of the z-axis presents the rotation speed, which can be used to detect left turn, right turn, and lane changes. We can use the statistic data of the left turn, right turn, and lane changes to present the features of the driver's behaviors. We will give more details in the next section of the basic results. This figure shows the acceleration of y-axis. In our case, the y-axis presents the horizontal acceleration, which value presents the stability of driving straight. The red arrow points while the acceleration value close to zero. That means a driver is driving in a period of stably. This feature is very important because we can use the feature to present whether a driver is good or not, because driving stably is very important to be a good driver. The acceleration of z-axis. The raw data of acceleration of z-axis. Depending on how the phone is mounted in the car, in our case, the z-axis is the driving direction, so the acceleration of the z presents the driver's speed acceleration, which means we can use the acceleration of the z-axis to present the speeding up and slow down patterns of a driver, which is also a big important effect to define whether a driver is good or not. The angular speed of the z-axis. After smoothing the raw data, we can tell from the figure that the blue arrow point where is a left turn pattern. The red one is a lane changing pattern. The black arrow point is a right turn pattern. We can use the statistical data of the left turn, lane changing, and the right turn to determine whether a driver is a good driver or bad driver, or even we give some scores of the lane changing, because as a good driver we're supposed to do less lane changing. In terms of the future works, I think the first important one is we need to collect more data to do driver behavior analysis to improve the accuracy of our mobile application. Unfortunately, due to the coronavirus, we are unable to go outside and for data connection. Secondly, I think it's important for us to retrieve more driving features from the sensor data, and also to seek new machine learning algorithms which can classify the driver behaviors based on the driving features. Lastly, hopefully we can collaborate with the insurance companies to testing our mobile application with their customers. In that case, we can improve our mobile application and also trying to find some business values for this project. This is the references we used when we do our research and also implement our mobile applications. Thank you for your listening. This is all our project presentation.